Okay, so we've got particles going off, and then in the particle shape node under emission attributes, we can set the max count to something like just 10. Right now, so I'll just shoot hit return 10. So it just shoots out 10 particles now. So what we're going to do is add a little script to this that's going to record the position of each particle at every certain number of frames, and then make a control vertex on a curve. And then so we'll draw a curve behind it. So we've got the script not in there, but in here. So this is for, this was written before we had n particles, so instead of called n particles, they're called just particles. And so let's just look at what it says here. So in the creation expression, we're creating a new attribute, or sorry, a new variable. And it's a vector variable because it's got 3 values in x, y, and z in space. And it's going to hold the position of each particle. So when each particle is born, it's going to record the position and put it into this container. And then when you create a variable like this that starts with string, it means you're just creating a word or a series of numbers. So it's just something we can do to name new things that are generated, because we're going to create new curves. And so we want to name each new curve, curve underscore, and then the particle number that it was generated from. Let's forget about this for a second, because this is just a way to delete curves when we rewind the animation. But this is the more important part. So the first thing that happens when we run this animation, so this is all in the creation expression, we're going to tell it to create a new curve. And it'll be empty, but there'll be a curve node. And we're going to get its position, so the flag P, dash P is the flag for position, and we're going to get that data from this variable up here, $POS. We're going to get POS.x, .y, and .z. So that's the position of the particle when the particle is born. It'll be right at the middle of the world. So right at creation, this will be 0, 0, 0. And then dash n is the flag for the name of the node that was just created. So it'll get the name curve name, which is this string that we made up here. So that creates, on birth, a particle is born, and a curve will be created and named according to the name of that particle. Okay? And then a runtime expression is one that runs every frame after birth. After birth, that sounds horrible. After the particle is born. So we still have to declare that position thing. We still have the string for the name. And then we've got an if statement here. We'll talk about that in a second. But essentially, if this was in here, on every frame, we would run this new command, and it would say curve append. So rather than create, we're going to add to an existing curve. So it's going to append the position of the particle on every frame. So on frame 0, the particle's at 0. On frame 1, it will be some distance away from the origin, and we'll record that position there and leave a control vertex there. Next frame, it'll be a certain distance away. It'll record its position and append a new control vertex that will add to the curve. Okay, so what's this thing? This is a way to make it not do it on every frame. So we can say if the frame number, so divided by 5, is equivalent to the frame number divided by 5, but truncated, then run this. So what does this mean? So if the frame number is 6, then we would have 6 divided by 5 would equal 6 divided by 5 truncated. That just means, when you put truncated, it means there's no remainder. There's no decimal point. So if the case were that the frame number were 5, it would be 5 divided by 5 is equal to 5 divided by 5 truncated. There's nothing to truncate, so they're the same. So every 5th frame will run this little code. There are other ways to do this to modulate which frames it's evaluate on. There's one called fmod that does the same sort of thing, but this is just kind of a hacky way to do it, but it works. Okay, so let's try this. So I'm just going to copy and paste this stuff because I'm lazy. So where do we put this stuff? Well, we put it in the per particle array attribute. So position already exists as a per particle array. So we're going to right click and just say creation expression, and we can paste this in here. It's got the background on here, so I don't know if that's going to cause a problem. So I have to change the name because it's n particle shape, not just particle shape. And it should be a capital P. And I'm just going to hit create to see if that white background is going to cause a problem. No, that's good. Okay. And then we want to create a new name for each curve that's created. So string curve name equals curve plus n particle shape 1 particle ID. Okay. Edit. I don't get a warning. I'm just looking for warnings down here, and it's not turning red, so that's good. And then there's other stuff here, and we'll come back to this in a minute. And then we want to put this in the runtime before dynamics. Could be in the runtime after dynamics, doesn't really matter. That would matter if there's a turbulence field or collisions, whether it evaluates this before or after those things happen. So just get rid of this. Vector position, so I'm just going to rename these things. So everything else should be good. Okay, so now if we rewind, play, we get a warning. An execution error occurred in the runtime before dynamics, so let's see. And particle shape ID, and particle shape 1 particle ID, particle shape should work. I'm just going to clear this. Just typing it again. So we're just declaring that variable to be a vector and contain that position information. So let's say if I'm going to do the string curve name again. Copy that. Okay. So if the frame divided by 5. So when you have two equal signs, that means is equivalent to, so it's asking a question rather than declaring an equivalency. Equals trunk frame divided by 5 bracket bracket. Make sure I don't get a warning. Oh, actually I don't need a semicolon yet. And then these curly brackets are just used to separate the if statement from its function or from its result. So curly bracket, curve, and position, and then pos.x. Let's copy and paste that. Change this to y and z. Let's make sure I got that right. To the curve name. I'm worried now it's not going to work. Execution of the runtime for dynamics. No object matches name curve 0. Okay. Oh, because I forgot to put in the create curve line. Well, that makes more sense. So it was going to create a curve with that position. So hopefully that works. So now it's generating these curves. And you can see how often it creates a vertex there. Now if I rewind and play it again, you can see that it's just recreating the curves, and we're starting to get a huge stack of curves here. So remember, there were 10 particles, but I've got 20 curves now. So we want to add something to the code to get rid of those. So in the creation expression, we're just going to ask Maya to look and see if those curves already exist. So we're going to create a new variable called obj_test. So it's an integer. So if, and it equals, this is a command in Maya called object_exists. So obj_exists. So this is just a command you can run to see if there's something with this name in your scene. And when you have these two little tick marks on either side, it means that this variable should contain the results of this command. That's what those little tick marks mean. And then we're going to say if that does exist, so if it equals true, 1, then ignore this garbage. And then all it has to do is delete that curve, and then it will recreate it. So we can just copy this because this doesn't have any unique names in it referencing that particular particle. Okay, so we'll run our creation expression, and we'll do it in between here. So I missed it before. And then I put a little print in there so it tells us if it does something. So that should show up in the script editor. Okay, we run it once, go back, and it tells us that it deleted it. Okay, so now if we select that particle, and we can just create a turbulence field to get these things moving around a little more interestingly. Don't need that. Okay. So we can trace the particles like that, so we can get something a little more interesting. Now the other thing we can do, if we rewind and place, let's say a cube, or not a cube, but create a sphere around the emitter and turn it into a collision object, so a passive collider. And then I'm going to just turn its visibility off, but it's there. So we can rewind, play the animation, and now they'll be stuck inside that thing. So that's how I made the chromosomes. Actually, I just put them inside one of these things and kept it in. And the chromosomes, the different chromosomes have a different length based on their number of base pairs. So for each one, I ran it separately with an if statement saying, if, what did I do? I set a different lifespan for each one. So for particle 1, if particle 1 equals, how did I do it? Like number 1 was much longer than number 22, so I just had number 22 die earlier. I just can't remember what I did. It was just an if-then statement about the number of frames that it reached. So if you want to use this to grow something out, then there's then the next question about how do you render a curve, right? Because we've got this thing, and I'll delete this, and I'll turn my magnitude of this down a little bit. Just get them moving. So if we want something to grow out like this, in Maya you can't just render a curve, but what you could do is put a piece of geometry on here, like a tube that would grow, or you could put paint effects on here. Actually, I haven't thought about this because I didn't know we were going to do this today, but just so we can see, if you select a curve and go into the paint effects node. So paint effects is two things. It's a way to render curves and a way to grow plant-like things off of surfaces, bifurcating hierarchical based things like trees, flowers, and stuff, but it's used for other things like hands. Here you can see fire, lightning. But if I selected something like this, and then select this curve, I can never remember where all this stuff is. Effects, paint effects. Didn't I go through this last time? I can't find anything. Where did I put paint effects?
It's under Windows. Paint effects.
Yeah, this is the, so you can use Maya to actually paint 2D paint effects too. This is the paint effects window. I need the menu set that has all of the paint effects stuff. There used to be one in here called FX.
They changed a lot of the paint effects stuff to generate.
Generate. Where's that?
Right side. Side UT.
Ah, thank you. Yes, yes. Thanks. I'm stuck in my old ways. I can't remember anything new. So if I select this curve, and I go to Apply Settings to Selected Stroke. Oh no, sorry. Curve Utilities. Attach brush to curves. Then it's going to attach this brush to this curve. Now I think if I rewind it, it's going to probably not come back. It's following the same path. See if it grows it any longer. No. Okay, so let's look at a different way of doing it. A procedural way. So let's say the only thing is that if these curves are recreated new each time, all the procedural stuff won't work. So it'd be probably better to grow the curve out like this and then attach the paint effects to it. You can grow the paint effects. So if I do that again, and if we open up the paint effects tab here, I've got these end bounds so we can animate this thing growing along the curve like that. So you could animate these sort of things coming out. You could also make this a dynamic curve. So once you grew it out like this, you could make it dynamic so it could move slightly and then have the paint effects grow along it too. What were you thinking of doing specifically? Is this your infection ball again?
I don't know, just like have it just like look like it's growing and more. There's a part where the pills get really high.
Mm-hmm.
At the beginning, like it sucks in the pills and gets smaller, but then it starts like rejecting the pills and it becomes like resistant.
Yeah.
So I don't know.
You might want to, you could do something like that with like a bundle of particles because they could collide with something like an instant pill. And so and if it was a pill that was instanced to another particle that you shot at the thing, it could be sort of engulfed by it if you surrounded it with like a piece of geometry. And you could control the size of the particles and their collision attributes so they could shrink together or push apart. You could do something like that and have it'd be more of just a moving mass rather than sort of a stringy kind of thing. Yeah, so this, I guess the limitation for this is that these curves are created new each time. So if you applied an effect to them, like I've used this before, like I said, to actually grow something, but then delete the dynamics and retain the curves to use for modeling. To get this kind of random modeling is kind of difficult. You could make sort of a bundle of fibers like I made inside that sphere, then remove them from dynamics and then make them themselves dynamic. And they could be just the mass of fibers that are moving around. And you could shoot particles into it and they'll react to it. Things like that. And you could get pills stuck in it, things like that kind of effect. That could work. So try that. I mean, it's all right here in the wiki if you want to set this up. But this is actually a really useful. I'm doing a workshop on this in spring at a conference. I'm going to use some of these examples for modeling with particles. Okay. Okay, so let's change gears quickly, and we're going to look at rigging, a rigging example, then we'll look at the bullet rigid solver. Then you guys can try that out. It's already 2 o'clock, so. So Brittany's working on rigging a skeleton that has to be able to move, and this is not sort of an uncommon, well, rigging a skeleton is not that common, but having to build rigs to do different things is not uncommon. And we looked at building some basic skeletons, or sorry, not skeletons, but joint systems. You know, if we wanted to do an arm, you have a forward kinematic arm like this that you can animate by rotating the different joints, or you can insert an IK spline, which reverses the order of operations, where by moving the child, it forces the parents, the elbow and the shoulder, to have to rotate. So that's good for things like arms, where forward kinematics for walking and swinging, and for legs, because you have to have a shifting pivot point when one leg is on the ground and the other. Inverse kinematics works well for that. But then you've got things like a tail or a spine, which isn't really swinging, but it does have to twist and bend and things like that. And it becomes difficult to manage because there are so many little pivots within it. You do need lots of joints, but you don't have to control them all separately. And that's where we can use the IK spline. Now, we used that before to make it a dynamic curve, so you could make something move around naturally. But let's look at a way to do it for more of a character animation type thing. So I'm just going to build a little character model here. So just bear with me for a sec. So I'm going to make the legs first, so I'll just do that from the side. I'll do it on the ground plane here. So I'm just going to create a skeleton. So joints, so I'll do the hip up here, and then the, what do you call that, the knee, right? Ankle, go down to ankle, ball, toe, so the ball and the toe, so something simple. I'm not going to do the whole reverse foot setup where you put in the heel as well, so you control rotation about the heel, the ball, and the toe. We can do that later. And in the front view, I'm just going to grab this thing and move it over a couple of units. Nope, but mine's going to decide to crash instead. Okay, sometimes I think it's because I've got the screen recording stuff on that it makes it a little unstable. Okay. Luckily I didn't get that far, so let's do that again. Let's save this as spine rig. And I want to grab this, move it over. Oh, phew. Okay, I'm just going to snap it. And then I'm going to draw the spine quickly. So, and I'm just doing this roughly. So I'll just create joints and starting down here in the lumbar region. This guy's got quite a curve. Going up to the neck. It's a hunchback. So something like that, and then we'll build the arms out. So let's hit Y to relaunch the tool. Hand. So I want to, so we open up the outliner. There's my root joint, there's my leg. So I want to make the leg a child of this root, so I can just middle mouse drag it on top in the outliner and it'll make a connection for me. And I can just duplicate this leg at the hip and then move it over so to get the other side. I'm just going to draw another arm. And then I want to connect them here up at the neck. So I can select that one, open it up. I just want to make these ones children. Okay, so we have a simple model of this weird looking guy. He's got tiny legs. So I'm just going to put a quick little rig in the leg so I can lock his feet down. So I'll just create an IK handle to go from his hip to his ankle. Hit Y to do that again, hip to ankle. So now we've got just a simple setup so we can move the legs. But I'm going to keyframe them into position. Now normally you would have, like I said, the reverse foot. It's like a kind of a shoe you put on here to control the movement of the whole leg by moving just the foot. But if I just keyframe the IK handles, then they'll lock into place. So now if I grab his hip, the legs, well, with the reverse foot it keeps the toes from going through the floor, but now he's locked onto the ground. We could do the same thing with the arms. So if I just hit Y again from the shoulder to the wrist, Y from the shoulder to the wrist, and we can control the movement of the arms with the IK setup. So that leaves us with the spine here. We want to create a curve that will allow us to control all these separate little joints without having to grab them individually to rotate them. And an IK spline or an IK handle is not going to work in this case. I'm just going to save this before it crashes. And I'll go into the side view and I'm going to draw a curve that sort of matches the shape of the spine here. So let's go to Create, Curve Tools, CV Curve Tool, and I'll just start down here. No, actually, I'm not going to do it this way. You could draw your own curve, or when you create the IK spline, you can have Maya create it for you. So we're going to do that, actually. That'll be easier. So if I go to skeleton again, instead of selecting create IK handle, I'm going to create IK spline handle. And I want to make sure that Maya creates the curve for me, but it doesn't simplify it for me. I'm going to simplify it myself. And this is in that tutorial that I sent to you, Brittany. Okay, so to make an IK spline, you just want to select the lower level root here, and then up here between the shoulders. And so you can see it creates an IK spline for us. So that means if I grab this curve and grab its CVs, I can control the shape of the spine. But it's got still too many CVs to make it easy to control. So I'm just going to hide everything and then show curves. So we can just see the curve here. And if I go into CV mode, oh, it's not going to show the CVs until I turn that on. So you can see it's got, I don't know, like 12 CVs or something. So it's too granular, the control. I want sort of broader changes, so when I bend the back or twist, it sort of propagates down naturally rather than being controlled individual spaces. So I'm going to select the curve and rebuild it. So under curves and way down at the bottom, rebuild, I'm just going to change the settings here. So I want to have set the number of spans. So a span is going to be each segment of curve that's created. So the first span always takes 4 CVs to create because it's a cubic curve, so you have to create 3, then the fourth one will create it, and then every other span just takes 1 extra. So by doing 2 spans, we should get 5 CVs. So 0 to number of spans 2, and then we want to make sure it's cubic. So cubic just means that it curves. If it was set to linear, it would be a linear interpolation between each CV, and you'd have a jagged curve. We rebuild. So now we've got fewer points to control the whole thing. And so this is what we're going to want to animate when we move the spine around, these CVs. But it's never a good idea to try and animate something based on its components because they don't have transform nodes. So there's nothing to record their position in space. So instead, we're going to select each of these things and create a cluster. So that's a deformer we've used once or twice before. And it just creates a transform node for components. So I'll create a cluster here, and we're not going to see it because I've got that turned off, but if I turn deformers back on, then we'll see that. And just continue. So select that one, I'll just hit G to redo the last action. G, G, and G. So now we can select these clusters without having to select the curve. We can move it around to change the curve. So now let's show everything again. So now we've got our guy, and we've got these clusters. We can grab them, and they're going to control this. So now we want to give ourselves some controls to make this a little bit easier. So what do we want to do here? Yeah, we want to create a hip controller and a shoulder controller. So if I just create a NURB circle, I'm going to put this around the hip to make it a little easier to control. Just going to snap it up here. Oops. What is going on? He's grabbing the wrong thing. I will just move it by hand instead. And then I'm going to duplicate this and put another one around his shoulders. So now what we want to do is just do some parenting here. So I'll call this one our hip controller. And this one will be our shoulder controller. And we can just parent some of these things here. So if I select this or this bottom CV, I'm going to turn off my curve selection for a second. So just select that, cluster, select P. So I just hit P to parent one to the other. So now the cluster is a child of that. And if I do the same thing with this cluster, shift select that, hit P again. So now when I rotate this, you can see the spine is following that. Then we'll do the same thing for the top two clusters here. So the first one here, shift select the shoulder controller and parent. This cluster, shift select the shoulder controller and parent. And then we can rotate this to control the back. And then we've got this one in the middle. And we want this cluster in the middle to pay attention to both the hips and the shoulder. So we can't parent it to both because parenting is an exclusive thing, but we can constrain it to both. So if we select the hip controller and then shift select the cluster here and go to constrain, we can just do a parent constraint and then do the same thing from here to here. So you always select the thing to be constrained last. So now, if we move this, you can see the middle one is moving. It's listening to this, but it's also listening to the shoulder controller up there. So if we move this one, you can see the backbone moves. So this allows you to get sort of natural motion along the spine without having to individually animate these things or have so many points. You're just reducing the number of points that you're using. In fact, you're kind of reducing it just to these two curves. Now if we move this around, we might want to also make this hip joint, which is our root of the whole skeleton, constrained to this curve too. So I can select the curve and shift select the root and just do a parent constraint there too. So now if we grab this, we can move everything around. We can get sort of natural motion like that. And I think this would help with sort of making the motion along your backbone a little smoother. Did you have something like this?
That's actually how I did it.
Oh, you did it?
Yeah.
Oh. Because then there was something weird about, maybe it's just because you had them parented rather than skinned. I don't know.
Yeah, I think the skinning thing might work better, but with the joints, because like when bone moves, the bone would like move into each other
Yeah.
or things like that.
Yeah, so you might want to think about what you can live with, like from what you can see, to simplify the rig. Anyway, I thought it was a good opportunity to show this sort of setup for everybody else. Even if you're not doing character animation, this spline IK can be useful if you had a long DNA rig or something that you wanted to be able to shift into different positions easily. With a spline IK and a bunch of clusters along its length, you could move that around.
I don't know if there's a way to do it, but I was thinking about it, and I feel like
for the bone, like the bone would stay the same, but
Mhm.
the like intervertebral disc would probably move slightly. But
Yeah.
I don't know if there's a way to rig that so that it's like only just that's moving, but the bone stays solid.
So what you could look at doing would be maybe something like this. So if let's say I'll just take two spheres to kind of simulate the two proximal vertebrae. So just duplicate these two. And let's say I want to have a membrane between them that changes shape as these move. So how can I do this? So if I take these edges, and let me just think for a second. I'm trying to think of a way to generate a curve that's stuck to the surface of both of them, and then you can loft a surface in between them. That could be the intervertebral disc, and then as those vertebrae move, that will change shape. So if I do polygon edges to curve here, I'm just not sure if this sticks to the surface. Yeah, it does, okay. So let me try that with this one. So I'm just selecting an edge loop here. So I'm just selecting a curve, double clicking it, and it selects a ring of edges going around there. And then going to modify, convert polygon edges to curve. So now I've got two new curves here in my scene, poly to curve 1 and poly to curve 2. And I could select these and loft between them. So lofting is just a way to draw a surface between two curves. I can already think of things that are going to go wrong here, but we'll give it a shot. Oh, it worked. Oh my god. I should say that every time. So now, you see if I move this, it tries to stay stuck between. So on your vertebrae, if you did that, if you had a curve on the vertebral body of each one and then just lofted between them, you could make something like this that would, and if the vertebrae were parented to those joints, so they don't deform, they just move, but then these would move in between. Now there's a lot, that means you'd be building up a lot of history between a lot of objects, and so it's always the potential that things could get a little wonky, but that would be one way to do something like that.
I thought that would be more realistic than just
Yeah.
hitting it or something. I was trying to think of ways that it might.
Yeah, so you want something that will sort of update procedurally like this, so as something else changes, it follows the conditions that are newly set. So you could try something like that. I would try it just like down in the lumbar region or something, delete those intervertebral discs and see if you can model something else. I mean, the other thing you could do, I suppose, is if you model just one long cylinder that kind of went through all the vertebrae, and it was skinned to the joint system rather than parented, so it would deform with the joints, but the vertebrae would just rotate. There's always a chance it wouldn't line up exactly, but if you had one joint for each vertebra, which you'd have to have, I suppose, if you're rotating each one separately, and then you have your spline IK, you could skin that cylinder of intervertebral disc that goes through all of them, and I guess it would kind of go through, it would just go through the bodies, right? Because it would go through the inferior part of the body and out through the superior part and follow that curve along. You could try that too. That would just be one piece of history that it would have to remember rather than all these separate ones. So you could try that first, because that's easy to try and set up.
Yeah.
You can use that IK curve to actually generate that piece of geometry by selecting that curve, making a circle, and extruding that circle along the curve. So it follows it exactly. Okay. All right, we've lost Susan. She's sleeping. She's snoozing. Snoozing Susan. Yeah. It's my mellifluous voice putting you to sleep. Okay, last thing. Ha! This is like a grab bag of goodies today. It's a non-stop action. Okay, I'm